Alrighty. Although it may sound like the British invasion, I promise we are not under attack. I'm trying to work out where to stand. This is a stray piece of information. I am not the Planetary Science Deputy Division Director, but I am a program scientist within the Planetary Science Division. And I'm very excited to be able to tell you about some of the highlights from our last year. So let's dive right in. I love showing this chart. This is what we call our fleet chart, our full portfolio of all our missions within the Planetary Science Division at NASA. So there's almost 40 missions on this chart. It is truly a great time to be a planetary scientist. What you're seeing is two separate swirls. You see the inner swirl, which is all our missions at the moon or at Mars. And then the outer swirl is all our other missions throughout the solar system, truly throughout the solar system. We have Bepi Colombo currently on its way to Mercury orbit, arriving there in 2026, all the way through to New Horizons, which is past Pluto, still exploring the Kuiper Belt, and lots of places in between. So the colors here represent basically what stage in the mission life cycle they're in. So the ones in yellow and in orange are still in development. They're still here on Earth. The ones in green are the ones in space. They're in their primary mission operations. And then the ones in blue are slightly longer lived, and they're in extended operations now. I'll also point out that some of these missions have little globes next to their names, and that indicates the international partnerships that we're very proud to have with our friends at ESA and at JAXA for several of these missions. So I'm not going to have time to talk about all of them, but we will hit some highlights. So January started with a little bit of bittersweet news. We had to say goodbye to our beloved Ingenuity helicopter on Mars. So Ingenuity was a little stowaway with our Perseverance rover. They landed on Mars in 2021, and Ingenuity was included as what's called a technology demonstrator on this mission. It wasn't there to do science, didn't have any science instruments. It was literally there to perform 5 flights to demonstrate that we could fly on Mars, and that we did. We had a Wright brothers moment in April 2021. I think I said they landed in 2019. That was not true, 2021. We had a Wright brothers moment where Ingenuity became the first powered controlled flight on another planet. And what you're seeing up in the what's that? The left, as you're looking at it, is one of those flights it took, 54. Flight 54. As I said, it was supposed to take 5 flights, and it did that. And then we were like, we're not saying goodbye to this yet. We want to keep flying it. So we did. And we did. And we did. And we kept pushing the limits, seeing we could fly faster, we could fly higher. And then in January, it took its last flight, number 72. And what you're seeing down in the bottom there is an image of the shadow of one of the blades of the helicopter. Basically, flight number 72, there was some kind of collision with the surface, and you can see that blade is now broken. It can no longer fly, but we can still talk to the helicopter if we're in range with Perseverance. And so what you're seeing here is actually one of the last images we took of Ingenuity right here in its resting spot in Valina Hills. So we had to say farewell and thank you to Ingenuity, but it really did change the paradigm with which we can think about exploring Mars in the future with aerial dimension. And so let's talk Perseverance as well. Perseverance marches on. This video is just showing you the journey it's taken so far since it landed in 2021. So it started off this is in the Jezero crater area of Mars. It started off in the flat valley floor. It's kind of made its way up through a delta deposit, or remains of a delta deposit. And now it's kind of making its way up some steep slopes of the crater walls up towards the crest of the rim. And you're also seeing, as it goes along, some green dots, which is where it's collecting samples. So as of, this is up to date as to the end of October, but as of now, Perseverance has driven more than 30 kilometers on Mars. It's collected 24 of these rock samples and an atmospheric sample. They're going to be vital for us to collect one day with Mars Sample Return. So the reason we went to Jezero Crater is because of its geological diversity and the fact that we have evidence of a river that once flowed into a standing body of water in the Jezero Crater. And on Earth, we know those are the conditions in which we have the first life forms preserved. So we think if we're going to go find life on Mars, or extinct life on Mars, then this is one of the best places to do it. And that is Perseverance. One of Perseverance's main aims is to search for signs of ancient microbial life. And so this summer, we had a little bit of excitement when one of those rocks that we collected with Perseverance showed some very interesting things. And this headline from the New York Times kind of sums it up. We didn't say we found life on Mars, but we found a rock and we're very excited about it. So that rock, as Nikki mentioned, is nicknamed Chayava Falls. And it's got some very interesting features in it. Basically, some of these features could be of a biological origin, but then again, there are explanations that could have an abiotic explanation as well. So Perseverance has done everything it can to look at that rock, to take all the measurements we can, and the Perseverance team is now in the process of getting that data out and publishing papers that will really evaluate the evidence we've got. But really, we're never going to probably know the answer as to whether those interesting features in the rock are produced by life or not until we get it back on Earth, and we can really interrogate it with all the state-of-the-art laboratories we have here. So stay tuned on that one. So Perseverance is our youngest Mars mission, but let's talk about our oldest Mars mission, Mars Odyssey. So Mars Odyssey is a workhorse. It launched in 2001 and has been in orbit for more than 23 years. And we celebrated its 100,000th orbit around Mars this year. Mars Odyssey has been an incredible producer of science. It helped us create the first chemical and mineralogical maps of Mars' surface. It still helps us study things like clouds and fog on the planet, and which will really help us in making future landings on the planet safer. And on top of that, it really plays a fundamental role in what we call our Mars Relay Network, which is the series of satellites we have around Mars that help us communicate with our landed assets, our rovers on Mars. So long live Odyssey. And then another of our long-lived Mars missions that were celebrated a cool milestone this year was MAVEN, celebrated 10 years in orbit. So MAVEN's mission is really to study atmospheric escape at Mars. And in doing so, try and understand the climate history of the planet. And what's cool about the fact that MAVEN has now been there for 10 years is that it's seen almost an entire solar cycle at Mars. And so the solar wind atmosphere interactions that we have at Mars are part of that driver of atmospheric escape and erosion. So by seeing this full cycle, we can see how that changes over time with solar activity. And then what you're seeing on the right here is actually images of aurora taken by MAVEN at Mars. So hopefully some of you got to see some cool aurora on Earth this year, but MAVEN is showing us that aurora are not just for Earth, they're for Mars as well. So let's move a little closer to home. So this year was a big year for the moon. You may have seen a little eclipse we had back in April, and just remember you can't have an eclipse without the moon. But we also in February saw the first US entity land on the surface of the moon since 1972, when Apollo 17 was on the surface. And so what you're seeing here is an animation of the Odysseus landing. This was a mission from a company called Intuitive Machines, which is part of a relatively new initiative we have at NASA called the Commercial Lunar Payload Services, or CLPS. And so in this initiative, we partner and we contract commercial entities basically to deliver our science payloads to the surface of the moon. So yeah, like I said, this is them landing on the surface of the moon, well, the animation of it in February. This Odysseus lander carried 6 science payloads for us. And it didn't have a perfect landing on the surface. It kind of ended up on its side. But we were successfully able to turn on all those science instruments, get data from them all. And so this was really a success to celebrate. And we're really excited to see how this program will continue to grow and how we can continue to deliver important science payloads at a regular cadence to the moon through this program. Let's talk OSIRIS-REx. So some of you may remember back in 2020, we punched an asteroid. So OSIRIS-REx, our mission, went to asteroid Bennu to collect some material, and that it did. So in October, it collected this material from the surface of Bennu, which is a carbonaceous asteroid, and then that material got locked up nice and safe in a capsule return, and then the spacecraft made a return journey to Earth, dropped off that capsule, came through the atmosphere and landed beautifully in the Utah desert last September. And since that time, it's been transferred to the Johnson Space Center in Houston, where the team have been working extremely hard to document that material and get it out to scientists around the country and around the world. And so we collected just over 121 grams of material, which doesn't sound a lot. It's about the weight of a little hamster. But it's actually the largest extraterrestrial material that we've collected from space other than through the Apollo missions. So this is really going to serve as a treasure trove for future generations of scientists as we really explore what Bennu can tell us about the materials that built up our planets, the very early history of our solar system, and even potentially something about prebiotic chemistry that led to formation of life on Mars. But you may remember that at the beginning of the year, made some news, made some jokes on some late night shows. We had a little trouble getting that capsule open and getting to all the material. And so, but all we needed was some clever engineers to just make the right tool. And that's what's showing up there on the top left. And literally once we had the tool ready, it took seconds to open that capsule. And what you're seeing here on the bottom right is some of the material. So some of the early science results are now coming out for OSIRIS-REx. We're seeing a sample that's rich in carbon and nitrogen, which we know are some of the essential building blocks for life. We're seeing material that's also surprising to the scientists. So the bright material you see in the class here are actually magnesium sodium phosphates, which was a mineral phase that we didn't see from orbit, from the spacecraft data from orbit. So this was a surprise to the scientists. And really all the evidence that we're seeing so far is suggesting that the material from Bennu has had substantial interactions with water, suggesting that Bennu maybe was once a wet world. So stay tuned for more science coming from OSIRIS very soon, in the next weeks and months. OSIRIS-REx. Let's move a little further out. Let's talk Juno. So Nikki just talked a little about Juno and showed this image, which again is showed in the science planners. And what you're seeing in the video on the left is a map of the magnetic field intensity at Jupiter. So Juno has been in orbit since 2016, and one of its main aims was really to try and understand the origin of the planet's magnetic dynamo and where that really originates from. So the question was whether that originates from higher up in the atmosphere, whether hydrogen is molecular, or deeper down in the atmosphere where the hydrogen gets compressed and becomes metallic. And so some of the recent results from Juno have shown that it does indeed come from that convection within metallic hydrogen deeper in the planet. And what you're seeing in the blue spot is what they call the Great Blue Spot. So the red areas in that map are where the magnetic field lines are coming out of the planet, and the blue is coming back into the planet. And so we're also seeing from the results some variation, secular variation in the magnetic field, and we think that's to do with movement of that Great Blue Spot over time. And again, this beautiful image from JunoCam on Juno of Io, which is the most volcanically active body in the solar system, and it's really showing that Juno is now a full Jovian system explorer. It's not just looking at Jupiter, it's looking at the Galilean moons as well. So it's done a series of flybys of the moons in recent years. And this was a composite, a result of some of those close flybys of Io, again, showing the sunlit portion of the moon on the right, and this Jupiter-lit portion of the planet on the left. And as beautiful as this image is, it's also scientifically useful. This is super high resolution. You can see things like active plumes. You can see mountains and shadows that they're casting. You can see lava lakes. So this is really exciting data for people that care about Io and volcanism across the solar system. I can't talk about this year without talking probably the biggest highlight we had. So Europa Clipper is our biggest, newest mission in space for planetary science. It's our latest flagship mission. And I was very privileged to be at Kennedy Space Center when it lifted off on October 14th on a SpaceX Falcon Heavy. It really shook our bones, and it's something I will never forget. So yeah, Clipper's now on its way to Europa. It's going to arrive in 2030 at Jupiter, or go into orbit around Jupiter, and will make, starting in 2031, 49 close flybys of Europa to really understand this ocean world. The first time we will really be studying an ocean world in depth with a mission. And one of its main aims is to investigate the habitability of this moon. So it's not a life detection mission. We will be studying habitability. So the idea is that Europa has potentially the three main ingredients we need for life as we know it. It has water, it has a source of nutrients, and it has energy. So with its full complement of science instruments on the spacecraft, we will be studying that ocean in detail and really trying to work out its habitability. So let's talk about what's coming up in the future. 2025, no rest for the wicked. So we're excited about some of the next CLIPS landings that are going to be happening. First of all, Firefly will be attempting their first landing on the lunar surface in the coming months, and that mission will host 10 science payloads for us. And that'll be landing in the Mare Crisium region of the moon with various scientific objectives, including studying heat flow in the lunar interior and surface plume interactions and much, much more. We're also expecting the next Intuitive Machines launch and landing on the moon in the coming months. The lander itself will have technology demonstration instrumentation, including the first in situ resource utilization experiment that will be on the surface of the moon. But we're particularly excited about this one because our mission Lunar Trailblazer will be launching with it as a rideshare. Lunar Trailblazer is one of our smaller missions in our portfolio, part of our Simplex program. And so Trailblazer will be launching with IM-2 and will go into orbit around the moon to study its water and to map its water and understand the lunar water cycle. And then Nikki also mentioned Lucy and the Dinkinesh encounter that happened last year. Lucy will be making its next asteroid flyby in April. It will fly by the main belt asteroid Donald Johanson as it continues its journey out to the Trojan asteroids, which share an orbit with Jupiter. And that Trojan tour will start in 2027. And then looking slightly further ahead, Dragonfly. So we're very happy to see Dragonfly confirmed this year. So Dragonfly is well on the road now to going towards Titan, expecting to launch in 2028. I don't know what to say about Dragonfly. I don't think there are words to describe this. This is audacious. This is incredible. It's mind-blowing that we're gonna fly a rotorcraft on Titan, the moon of Saturn. This is basically a flying chemistry lab. So we're going to really study a world that's rich in hydrocarbons, to understand the prebiotic chemistry, to potentially look for whether there is extant or extinct life on Titan. And we're going to do it by landing and then flying from site to site to really sample a diverse set of environments on the moon. And with that, I will say thank you.